Hi, and welcome to this month's version of the FDTD Goes Applications webinar. Today we're very happy to have Dan Baumgart, the Sioux from La Crosse, to talk about the satellite observations of an earlier than forecast explosive convective initiation. Next slide, please. This is part of a series of talks on satellite applications. We're always looking for speakers. So if you think you have an interesting topic, please contact myself, Scott Lindstrom, or Dan Bykos. You can see our emails on the slide there. Next slide, please. Just some protocol. We'll have about 20 minutes for the speaker. You can send questions via GoToChat, or you can just break in at the end for some Q&A afterwards. Don't press hold, and if you're not talking, please mute. That's all I have. Take it away, Dan Baumgart.
All right, thanks, Scott. Just wanted to thank you and Scott Bachmeyer for the imagery support, the loops that you made for me for this case that I incorporated into this presentation. Welcome, everybody. Thanks for taking a few minutes out of your day to join in and for this presentation. We had an interesting event in early June, and I just wanted to kind of look at some of the information that the satellite provided to help us in our operations, and maybe looking back, it didn't help us in real time, but kind of looking back at some of the hints that were in the satellite data that could have helped us maybe position ourselves a little bit better. So this is a pretty good event for us. Our CWA is, if you look at kind of southeastern Minnesota, that foot coming out there, western Wisconsin, and northeast Iowa. So really the triple point between Minnesota, Iowa, and Wisconsin is kind of the center of our CWA. These are just the SBC forecast. It was an enhanced risk day, and you can see in the lower right that it verified pretty well with mostly hail and wind reports, and some more large hail and pretty strong winds. Hail probably got up to about 2 inches in size, and winds were somewhere between 65 and 70 in some of the reports. So it did do well. We knew it was coming. It was well messaged moving into the event. And really the biggest challenge for us was when convective initiation was going to occur. Just looking at some plots here at 12Z to just kind of give you a feel for what the environment was like. Not a great deal of flow aloft, and in fact the shear was a limiting factor in this case for a higher end event. And we're thankful that it wasn't higher wind shear for this case, or it could have gotten really messy because as you'll see, we had incredibly steep lapse rates. There was a wave coming out of North Dakota and a slight gradient in the lower right. You can see at 850, there was a slight troughiness in there and a little bit of cold advection coming in. We were in a fairly warm air mass at this point. And at 700 in the lower left, there was flow off out of the west-southwest, and what that did was bring in an elevated mix layer and really steepen the lapse rates from Nebraska into Wisconsin. And typically in our area, we'll see the elevated mix layer come over, but usually it forms such a strong cap that we usually don't convect from it. But by 0Z, when the convection was now active, you can see that we had a wind shift and a trough coming in at 850, and really the shear was again deep shear was somewhere around 25 knots, so it wasn't a big supercell day. But this trough coming in caused us problems with convective initiation. Here's just a sounding from Minneapolis that morning. You can see the elevated mix layer pretty clearly. Nearly constant potential temperature and mixing ratio nearly uniform, and even some of that in the lower levels too. So pretty steep lapse rates you can see above the surface. The question was if we were going to break the cap. And again, the shear profiles, nothing really that interesting. Somewhere in the mid-20s for bulk shear, 0 to 6 kilometer. So we didn't see a whole lot of change during the daytime hours. And Green Bay, you can also see, if I just bounce back and forth between Green Bay and Minneapolis, you can see some of that influence of the elevated mix layer actually extending northeast all the way to eastern Wisconsin already that morning. So here's just a 15Z HER forecast for 22Z that afternoon. And you can see the soundings pretty fat there. The normalized CAPE is above 0.25. It's somewhere between 0.28 and 0.30. And then look at the lapse rates. I love this on the buff kit display that you can kind of look at what the lapse rates are from, this is 500 millibars to any of the levels that you see down below. We're over 8 degrees Celsius from basically the surface to 500. So that's pretty explosive if you're going to get storms, and you have to be really careful in that environment. Again, you can see the wind profile here, suggestive of pretty linear unidirectional wind flow, and not significant there to expect supercells. So we were expecting just a steep lapse rate, pulse type storm environment. You can see it's quite dry. D-capes were about 1400. So we're talking about wind and hail from this. And our idea was that it was going to come in the evening. Here's the 15Z HER run simulated reflectivity, and most of the convection comes into our forecast area after like 23 or 0Z. So we're thinking like 6 to 7, 8 o'clock for convection, and it was going to move in and not develop over us. And these were very consistent runs overnight all the way into the mid-morning, and then this HER started to change its tune. Here's an 18Z run. It started to actually get later, and if I run this again, you'll see some hint of failed convective initiation kind of midway through our CWA and east-west kind of line. You can see some light echo goes up, but it doesn't continue to develop. So really, we were actually just starting to back it out a little bit, and typically that's our problem with these elevated mix layers and our capping. We're usually too early with the convection in our messaging. So this was our graphic, our message that went out in the morning from the midnight shift. Basically, in the early morning hours, we had this to our customers. We actually had tornadoes in the forecast in the morning for this event, for the messaging, and then we pulled that later. But we had a 5 p.m. to midnight. We updated that around noon and changed it to a 7 p.m. to midnight, walked it a little bit later, a couple hours, pulled the tornado warning, and then just started to really focus on the wind and hail threats. But we were, basically severe storms are expected. We were talking it up. We started to issue some different products in our social media for large hail and hail damage to cars, park indoors, get it under cover, really targeting tonight. So here's our office strategy. 2 o'clock, our lead forecaster came in. 3 p.m., our general forecaster came in, and they were going to assume a mesoanalyst role in this and for this event. And again, we're thinking like, 6 or 7 local time, we're going to get storms to either move in from the northwest or get convective initiation as the cap weakens. 3 p.m., we had extra telework staff here that we could support severe weather. And then about 5 o'clock, we had 2 radar operators and a coordinator plan to come in. Everything looked like it was going to be perfect. And then the atmosphere said, no, not so much. That's not going to happen that way. So we ended up getting first radar echo about 4 o'clock. And you can see that causes a little bit of a problem. So at that point, we started to have to go into radar mode and retune all of our messaging. So it really threw us for a loop. And I'll kind of step you through some different things in the satellite imagery that we saw. The next slide, I'm going to just put in a loop here, and it's a 1-minute imagery from the Meso Sector that was over us, and it's really interesting. I want you, if you can, in this next loop, I'm going to show you, focus on this northeast to southwest boundary. It was just kind of one of the interesting features right here in this. Still, it's basically from about Minneapolis down to the southwest corner of Minnesota. And this is going to propagate southeastward, and it's a mid-level, it's causing mid-level cloud. That haziness in the cloud, that hazy cloud you see in the visible is about 11,000 feet at least at Redwood Falls, Minnesota. That's going to propagate southeastward, and I just want you to just kind of focus on the cumulus behavior just behind it. I'm not really sure of the implications of it, but it seems like it had some kind of an effect on the cap strength. So just I'll show you a loop of this entire event as it played out. You can see it's quite capped over most of southern Wisconsin, southern Minnesota, and northeast Iowa. And you can see you lose it for a little bit, but you see that northeast to southwest band kind of dissipates, but if you follow it with your eyes, you can see it showing up again in western Wisconsin into southern Minnesota, and right behind it, the cumulus field starts to develop more and get a little bit more agitated, but nothing out ahead of it. Out ahead of it, we don't see any cumulus development, only behind it. So it's kind of interesting. I'm just going to let this loop run again, and then you see the convective initiation occur in southeast Minnesota. It initially went up for about an hour. It was tame, and then it just ripped on a number of boundaries, and then we had convection come in from the north. So the initial radar echo was about 4 p.m., like I had mentioned, and so we were just scrambling to get people into the office, knowing that these steep lapse rates were overhead. I'm going to let that loop run one more time. And it's in the satellite blog that Sims put together for this event. And if you aren't getting a really smooth satellite loop of this, it's a phenomenal loop to just sit back and watch and get some popcorn and just kind of sit with. But again, focus on the cumulus field behind that line as it propagates southeast, where it's hard to say what that really is. Seems to emanate from the convection that was further northwest in central Minnesota. But it seems like it has some kind of an effect on the boundary layer cumulus development right behind it. So I'll just kind of let that go for a little bit here and switch to the next frame. So here's just a look at some of the GOES products as we walk through the day. We were not looking at these in real time. But one of the interesting things here is GOES CAPE on the left and lifted index on the right, and just the SPC enhanced risk is over the top. And just a reminder that these are under the derived products in the AWEPS for the National Weather Service forecasters that are on here. But really it started to key in 18Z, so this is 1 o'clock local, started to key in more on Wisconsin than it did. I mean, you're losing your field of view here that you can really get accurate measurements off to the west. But it really starts to focus your eyes towards Wisconsin more than it does Minnesota. And the HER would suggest that this convection was going to come in from the northwest from the convection that's ongoing in central Minnesota in this image. And you can see that in the IR enhancement over central Minnesota. So as we step through time, you get to like 19Z, you just see the Cape build. So I'll just kind of go back and rock that back and forth, and you can see the Cape build through 1930, and mainly in central Wisconsin and a portion of that southeast Minnesota area. So one of the things you can also look at is if you get the JPSS to fly over, you can get a new caps analysis. So here, if you go into the volume browser and select gridded new caps here, you can get some different parameters. Here's the totals. I was just trying to look at what that mix layer looked like aloft and what the steep lapse rates looked like, and how the polar orbiter would have assessed that. And you can see that axis kind of comes in over the top of that cape there. And so you can get a feel for where the steepest lapse rates are via that totals. And then the cape is just on the right here. So just an added idea there. And then here is the lapse rates from SPC at the same time the image is on the left. And you can see that our entire CWA is over 8 degrees Celsius in this layer. But you get a really good feel for where that elevated mix layer is emanating from and coming into the Great Lakes region. And as the day went on, it continued to spread eastward into the Green Bay area. And incredibly steep lapse rates there. Here are some, just wanted to go through the initiation phase and what the cumulus field looked like, and kind of my story and how we were working through the afternoon there as this occurred. I just wanted to briefly go over the RGBs because I know this is still tough for some people to get their head around. So we've got 3 basic guns here, the red gun, the green gun, and the blue gun. And in this day cloud phase here, the red is the simple IR that you're used to. So the colder it is, the more red gun you see. The visible, the brighter it is, or more reflective, the more green you have. And then the snow ice, the more water cloud you have, the more blue gun you get. So because the land is dark and warm, basically red and green are turned off, so you see a lot of the blues that show up here for the land. And so the cumulus fields, because they're basically water, will start as those blue clouds that you see there. So this is kind of the RGB wheel in the upper right of this satellite loop. And the convective initiation follows this trajectory around the wheel. So if you start here in the beginning with just boundary layer cumulus, which are water clouds and they're bright on the visible image, you get this cyan area where you start on this dot. And your trajectory as you get closer and closer to CI starts to go to green, then yellow, then really to orange with cloud tops that are colder. So we'll just kind of walk through that. So this is the event. I want to just point out a couple things. First, you see a wind shift pretty clearly, but it's quite warm behind it. It's drier. The temperatures are in the lower 90s. Dew points have fallen now into the 50s, mid-50s. Out ahead of that wind shift to the south of it, 91 over 68, 94 over 72. So, we're certainly in the north, we're approaching inverted V there. But pretty good lapse rates and convergence along the wind shift, but it's not really a quote-unquote cold front. But you can see the agitated Q developing there, and then the convective initiation. So just stepping through this kind of in the pre-convective phase. So you can see here that the agitated Q started to develop about an hour before first echo. This was 1956. Like I said, on these slides, you'll see the minutes to first echo on the bottom here. So 58 minutes to first echo. We started to see these boundary layer Q developing, and at this time I was working on a message. I was working from home, teleworking, but watching this imagery. So I was working on some messaging, and it actually came back to this image to see it. But let's go over to this color wheel here. So we're in the cyans now. We've got water cloud, and the visible is shooting, but the IR is still warm, so you don't have any red contributions. So you're in the cyan area. And then, so let's take another step forward here. We'll go forward about a half an hour, about 25 minutes or so. So this is 33 minutes from first echo. So I come back from creating some messaging, and I come back and I start to see this going more towards green, and I'm thinking, please, do not convect right now, man. So I'm channeling my inner Shaq here, trying to hope that this just stays at bay and we get convective, we get failure of initiation, because our messaging at this point is a couple hours off for our partners and the public. So you can see here the colors here now are moving towards green, and so we move a little bit further here. This is a 20-minute time step forward now. We're 13 minutes from first echo, and we moved a little bit more into green. You're starting to see the vertical nature to the clouds here in the cumulus field in southeast Minnesota, and actually some in central Wisconsin as well. You're starting to get some greens to be shown here. So we're starting to move around the color wheel towards convective initiation and getting some more vertical development as we get mixed phase, and we're just starting to turn those blue water clouds off now. So at this point, I'm pretty convinced that we're probably going to break the cap in some way. Something's going to happen here. We're starting to get mixed phase cloud, and SPC comes out then with a MCD about 10 minutes after this, and I highlighted the words that they use. Convective inhibition remains in place across all areas and is gradually eroding. And I just, I guess 30 minutes or 40 minutes is gradual, but not gradual enough for us in our messaging. So now we're starting to call people in at this point, especially after this one comes in, and we've seen the first echo now out of these storms on radar. You can see how yellow they are. We're really continuing to move our trajectory around the color wheel, starting to cool the tops now, so we should start to see some oranges in there if we continue to develop. And there's also an area over central Wisconsin that's also starting to get more, continue to develop. And then finally, this is the last image I'll show, but you can see the GLM data on top of that. On top of the day cloud phase image here. This is 37 minutes after first echo. And now you're seeing the oranges as you approach some IR red guns, the colder cloud tops and the red gun are starting to fire. The GLM data is over the top. You actually further west have some orphan anvils that you can see that are colored with orange tops here, where convective initiation had failed further west. But this entire area is trying to initiate now, and part of it has initiated. One of the things we were lucky with is that the first storms that did go up, they seemed like they were a little bit inhibited yet, and so that was actually a bonus. We had about 45 minutes before the first storm developed into a severe storm. So that bought us a little time to get the radar operators in and get our staffing figured out for this early initiation. So here's just a look at what the RAP convective inhibition looks like at this time. And you can see it's got a pretty good idea that the least inhibition is over of agitated cumulus. And so you can also see that cap kind of strengthen back to the west. But there's a lot of days where you're under this RAP, Meso type of SPC Meso convective inhibition where it's real low and you're just not convecting because the models just aren't handling the cap right. And there's a lot of details in the cap and how it's just the details in how the vertical temperature profile is compared to what the model thinks it's doing. So here's just kind of a loop from just after first echo to our first severe storm, which occurred near Winona. The storms were okay and they were behaved. They were near severe, probably dime-sized hail out of them. And then you can see the boundaries on the radar and the convection coming in from the north pretty fast. It just really kind of races in from the northwest and causes its own boundary to come in from the north. And this just caused a nightmare for the polygons because everything went up at really the same time, and we had storms really going everywhere. So this is only 1 hour and 15 minutes. So imagine yourself trying to handle this. And as warning forecasters, you know how this goes with polygons. Your first few polygons have a great influence on how your next polygons go and how you lay those out. So it was quite an event with these steep lapse rates in place. And we're lucky, again, we didn't have higher shear where we had to deal with a tornadic threat and rotating storms. So just a quick look at what one volume scan did for the first 2-inch hail report we had in Winona. You can see the 65 dBz core in 5 minutes how it developed. And the red line in the background is the -20 Celsius line. So you can see how high up that 65 dBz core was above that -20 line. It's incredibly impressive the way these storms grew rapidly. So just in summary, as we worked through watching the day cloud phase product, I think it really provided confidence that we were going towards convective initiation and got us more lead time to call some of our extra staff in there. We had to totally readjust our situational awareness. What we thought was going to be a forecaster dedicated more to Meso ended up having to work the radar, and we ended up having to obviously call in people much earlier. The 1-minute Meso Sector imagery, it revealed incredible details on the cumulus field and evolution, and some of that's unexplained. What that feature was that was moving through the visible loop from at mid levels and how that affected the cap. We did look at the low-level water vapor imagery with the elevated mix layer to see if there was some kind of a gradient in the elevated mix layer that we could pick up in the low-level water vapor imagery, and we really didn't see anything. It was really there was nothing to be gathered from that information when we reviewed it for this review. And then GOES and new caps, they provided a nice confirmation of the instability that was out there, and really comparing it to what a lot of forecasters like to use, which is like HER guidance and some of the model guidance as we lead into these convective events. It really pointed more towards Wisconsin than some of the HER guidance coming in from the Northwest. So unfortunately, these pieces weren't we weren't adjusting fast enough to these pieces, but I think it really highlights how having someone dedicated to mesoanalysis can maybe pull these details up and start to right the ship a little bit earlier than if you didn't have those dedicated resources. So I think that's about everything that I wanted to say on that case. So I can entertain any questions that you might have.
Thanks, Dan. Like he said, the floor is open for any questions. Just unmute yourself and start and ask a question.
Hey, Dan, it's Brian. Were you guys using the prop severe at all with this case?
Yeah, once we got into warning mode, we had that as a pretty normal overlay on our radar analysis. So yeah, this was the kind of day where you could warn on almost every storm that went up because you knew with the steep lapse rates that it was going to produce severe weather. So it was more about identifying the storms that were initiating and putting the warning out as fast as you could because you had very few storms. You had very little convective initiation that didn't go up in those steep lapse rates and produce severe weather.
Are there any other questions? If not, I'm going to say a big thank you to Dan Baumgart for the interesting talk. I always like seeing talks about Wisconsin weather. We will probably have another FDTD webinar in August, so stay tuned to your emails for that. Otherwise, thanks for tuning in and have a great day.